Lesson 3.5, Arithmetic Sequences as Linear Functions. Vocabulary, in this video, you will learn to recognize arithmetic sequences and also relate arithmetic sequences to linear functions. Your vocabulary for this section is sequence, terms of sequence, arithmetic sequence, common difference, recursive formula. Okay, so an arithmetic sequence is a numerical pattern that increases or decreases as a constant rate with a common difference. So it's a list of numbers that is increasing or decreasing at a constant rate, which means you're adding or subtracting the same number. And it kind of makes sense. If you know what arithmetic is, this is an arithmetic sequence. Arithmetic is addition and subtraction. So if you know what arithmetic means, then you can figure out what an arithmetic sequence is. You're adding or subtracting the same number every time. So whether it's adding 2 here, like it is here, or subtracting 4 each time, like it is here. Those are arithmetic sequences because each time the same number is added or subtracted. We call the number that you're adding or subtracting the common difference. So here, the common difference, D, is the common difference. We call it 2. And here, the common difference is -4 because we're subtracting 4. So we want to be able to look at a sequence and say whether it's arithmetic or not. So if we're going from here to here, from -15 to -13, we add 2. From -13 to get to -11, we also add 2. And from a -11 to -9, we also add 2. So because the number that I'm adding or subtracting is the same each time, we can say that's an arithmetic sequence. And we just want to say that our D is 2. So our common difference is 2. So that means it's going to be an arithmetic sequence. So we can say, yes, this is an arithmetic sequence because we're adding 2 every time. Okay, so looking at this next one. So from 7/8 to 5/8, that difference there, it goes down by 2/8. Then when I go to 1/8, from here to here, it goes down -4/8. So because these two numbers are different, this is not an arithmetic sequence. Okay? You guys try these. Okay, we also want to be able to figure out what the next term is going to be. So in order to figure out what the next term is going to be, we want to find the pattern. So from -8 to -11, it goes down 3. From -11 to -14, it's going to go down 3. And then from -14 to -17, it goes down 3 again. So we can know if we want to find the next 3 terms, we're just going to keep following that pattern. So going down 3 from -17, I'm going to get to -20. And then if I continue the pattern of subtracting 3 again, I'm going to get -23. And doing it again, going down 3, I'm going to get to -26. So my next 3 terms are -20, -23, and -26. Sometimes if you want to find a term that's way further down the road, like if I wanted to find the 100th term and I had that list of numbers, it would be annoying to do that. So we have an equation that would tell us how we could do that. And our equation is A of n equals A1 plus n minus 1 times D. We already discussed that D is the common difference. So how much it's changing each time between terms. But we want to know what n and an and a1 are. So n is the number term. So like it's what term you're looking for. So if I have a sequence of numbers, right? This is the first term, this is the second term, this is the third term, this is the fourth term, right? So here, these might not necessarily, like this would be 2, 4, 6, 8. So my first term is 2, my second term is 4, my third term is 6, my fourth term is 8. So n is talking about this number down here. This is our n. It's saying which term, which position is it in this sequence. Okay? A1 is talking about the term that's in the first position. So in this case, this is the first term. In this case, it's 2. And then AN is whatever specific term you're looking for. So in this case, if I said the fourth term, then AN, if I'm putting in N here is 4, that means AN is 8. It's whatever term is in the nth position. So these are going to be changing. Okay? So let's give this a try. So we want to write an equation for the nth term of the arithmetic sequence 1, 10, 19, 28. So we have our formula is AN equals A1 plus N minus 1 times D. So remember, D is how much is changing each time. So here, our D, it's going up by 9 each time. So our D is going to be positive 9. So I can put in 9 there. And it wants to find a term for the nth term. We don't know what the n is. We're just leaving n as n. Okay, and then AN, we're leaving as AN because we still don't know n, so we can't know what is in position n if we don't know which term we're looking at. But we do know A1. A1 is the first term in the sequence, which is 1. Now this is what I'm going to simplify. This is my equation. So I want to take this and simplify it. So I'm going to say AN is equal to 1 plus distributing the 9. I'm going to get 9n minus 9. And then combining like terms, the 1 and the negative 9, I can say that AN is equal to 9n minus 8. Now this equation can be used to solve for any value n. So if I want to know what's in the 100th position, I'm putting in 100 for n, and that's going to give me what's in the 100th position. So let's do this with the 12th term of the sequence. So remember our equation was AN equals 9n minus 8. So if I want to know what's in the 12th position, that's like saying n is equal to 12. So I'm putting in 12 for n. So that means the term in the 12th position is equal to 9 times 12 minus 8. So 9 times 12 is 108 minus 8, and I get 100. So that means in the 12th position in this sequence is 100. Okay? If I want to graph the first 5 terms of this sequence, okay, I'm going to set this up by doing a table or a chart. I'm going to have n on the x-axis and a of n on the y-axis. So my terms, the first 5 terms of the sequence were 1, 10, 19, 28. So I'm graphing 1, 10, 19, 28, and then the 5th term would be 37. So these are what I want to graph. So n, this is like the first position, second position, third, fourth, fifth. So I'm putting these down here, 1, 2, 3, 4, and 5. And I'm putting these terms here. So I'm just going to go up by 10, 20, 30, and 40-ish. So I'm plotting these points. I'm plotting 1, 1, which is going to be here-ish. 2, 10, is going to be here. 3, 19, here. 4, 28, and 5, 37. Excuse my graph isn't perfect, but you get the idea. It should form a line when you graph those points of the sequence. So which term of the sequence is 172? So remember our equation that we came up with was AN equals 9n minus 8. So I want to know when the term, I want to know what number n gives me a term of 172. So I'm putting in 172 there and solving for n. So I'm going to add 8 to both sides. And I get 180 equals 9n. So then n is going to be 20 when I divide both sides by 9. Okay, last one. The arithmetic sequence 12, 23, 34, and 45 represents the total number of ounces that a bag weighs after each additional newspaper is added. So we want to write a function to represent the sequence. So we're still using an equals a1 plus n minus 1 times d. So going from 12 to 32 to 30, these each are going up by 11. So that means that my d is 11. And I'm trying to write a function, so that means I don't know n, and my a1 is always the first term. So in this case, it's 12. Okay, so I'm simplifying this, so I have an equals 12 plus 11n minus 11. Combining like terms, I get an equals 11n plus 1. 12 and negative 11 is 1. Okay, the arithmetic sequence 12, 23, 34, 45 represents the total number of ounces the bag weighs after addition. Okay, so part B, it wants us to graph the function that we just got. So we got this equation, and if we were to graph it, it would look something like this. And then it says to determine the domain. So the domain are the possible x values. So that domain is going to be all integers. So 1, 2, 3, 4, etc. Okay. And that is the end of the lesson.